For years, astronomers have noticed strange behavior at the edge of our solar system. Far beyond Neptune, a collection of icy objects are drifting together in the same direction. Their orbits are clustered in a way that suggests something massive is influencing them. This pattern is highly unlikely to occur naturally without an external gravitational force. It's not Neptune or Pluto causing this. It's something much larger, farther away, and completely hidden. Scientists refer to it as Planet 9, a mysterious world that could be 5 to 10 times the size of Earth, orbiting so distantly that sunlight barely reaches it. Recent findings from old data, along with newly discovered objects, may finally reveal where it's hiding. Or perhaps we've been mistaken all along. Has Planet 9 been detected at last? Or is this the most significant scientific mystery of our time? Let's explore the evidence. In 2016, astronomers Mike Brown and Konstantin Batygin noticed something unusual. They weren't searching for a new planet but trying to understand why certain objects in the outer solar system behaved oddly. These weren't planets or comets. They're known as extreme trans-Neptunian objects, or ETNOs. These frozen rocks orbit far beyond Neptune, but instead of moving randomly, many follow aligned paths, tilted similarly and pointing in the same general direction. This isn't typical. In a stable solar system, distant objects should have chaotic, scattered orbits, not neatly arranged ones. The only logical explanation was a massive, unseen object tugging at them. Brown and Batygin calculated that if this mystery planet existed, it would need to be at least 5 times Earth's mass, possibly up to 10 times, and orbit between 400 and 800 times farther from the Sun than Earth. Neptune, by comparison, is only about 30 times farther. This hypothetical world would reside in a region of the solar system we've barely explored. They named it Planet 9, not only because it would become the 9th planet after Pluto's reclassification, but because no other theory fit the data. This was especially notable coming from Mike Brown, who played a key role in reclassifying Pluto. Their research wasn't mere speculation. They presented mathematical models showing how Planet 9's gravity could explain the clustered orbits of distant objects and even account for the unusual tilts of some known bodies. This sparked a global search. Telescopes scanned the skies, astronomers revisited old data, and amateur stargazers joined the hunt using online databases and citizen science platforms. Over time, more ETNOs were discovered, some with similar alignments and a few with retrograde orbits moving opposite to most solar system objects. Each discovery seemed to support the idea of a large, hidden planet. Yet, despite mounting indirect evidence, no one had directly observed Planet 9. Years passed, predictions narrowed, and search areas were eliminated, but every attempt to spot it came up empty. The orbital clustering remained real, and each new object fitting the pattern strengthened the theory. While not proven, Planet 9 became a major topic in planetary science because it was the only explanation that made mathematical sense. However, not all scientists agreed, leading to growing debate. Soon, researchers worldwide began testing the theory. Some aimed to confirm it, while others tried to disprove it. They ran countless simulations, recreating the solar system with a hidden 9th planet. In many cases, adding Planet 9 reproduced the observed orbital clustering, making the distant object's behavior more understandable. But skepticism arose. Some scientists, like Samantha Lawler and Jean-Marc Petit, argued the clustering might be a coincidence. They pointed out that the number of known ETNOs is small, and most were discovered by a few surveys observing the same parts of the sky at similar times. This could create bias, like shining a flashlight in a forest and concluding all trees are in one direction simply because that's where the light falls. This division deepened. Some researchers remained confident, citing the consistency of the clustering, while others demanded more data and broader sky coverage before accepting a new planet. Alternative explanations emerged. One group suggested a massive disk of small objects collectively exerting gravitational influence. Another proposed that passing stars in the solar system's early history disrupted orbits. A minority even considered modified gravity, though most scientists dismissed this. Planet 9 remained the simplest explanation matching the data, but the lack of direct detection fueled doubts. If it exists, why haven't we seen it? As predictions refined Planet 9's possible location, telescopes continued searching without success. Large sky surveys, including Pan-SDARRS, the Subaru telescope, the Dark Energy Survey, and archived data from the WISE mission, found nothing. The challenge lies in Planet 9's extreme faintness. Located hundreds of times farther from the Sun than Earth, it reflects minimal sunlight, making it nearly invisible unless observers know precisely where to look. Its slow motion across the sky, over weeks or months, also means most detection software, designed for faster objects, would miss it. Hope persisted that older surveys might have accidentally captured Planet 9 without recognition. Astronomers examined archives from IRAS in the 1980s, AKARI in the 2000s, and WISE in the 2010s. These missions recorded countless faint heat sources, but most were galaxies, noise, or artifacts. Still, the possibility remained that one could be Planet 9. Meanwhile, other surveys narrowed the search. In 2021, data from the Zwicky Transient Facility ruled out over half of Planet 9's predicted region for objects brighter than a specific magnitude. The OSSOS survey also found nothing, suggesting Planet 9 must be extremely dim, located in the far southern sky, or on an orbit different from expectations. Just when progress seemed stalled, an intriguing clue emerged from old satellite data. Early in 2025, fresh analysis of IRAS and AKARI archives revealed a faint, slow-moving object present in both datasets, 20 years apart. Its motion was key. Stars and galaxies don't move that way, but distant solar system objects do. This seemed promising. A possible direct detection of a cold planet hundreds of astronomical units away, with an infrared signature consistent with residual heat. Excitement surged briefly, but the object's orbit didn't match predictions. Planet 9's expected orbit is elongated but relatively flat, tilted 15 to 30 degrees from the solar system's plane. This object's orbit was tilted over 120 degrees, basically upside down, and moving retrograde opposite to most planets. Such a path doesn't align with the original models explaining the clustered orbits. Mike Brown clarified this object isn't Planet 9 but could be a large trans-Neptunian body or something entirely new. Instead of solving the mystery, this discovery complicated it, highlighting how little we know about the outer solar system. Around the same time, another discovery added to the puzzle. In 2017, astronomers found a dwarf planet with an extremely elongated orbit, stretching nearly 16 astronomical units from the Sun, far beyond Pluto's 49 AU. This object, 2015 OF2001, had an extreme tilted path suggesting powerful gravitational influence. Initially, it seemed like evidence for Planet 9, which was predicted to create such orbits. However, closer analysis showed it didn't fit the clustering pattern, breaking rather than reinforcing it. This raised concerns. If Planet 9 explains certain orbital alignments but new objects don't conform, does that weaken the theory? Some researchers suggested the pattern might be a statistical illusion caused by observational bias. They argued that 2015 OF-2001's orbit could result from random scattering over billions of years, influenced by minor interactions and galactic tides. While not disproving Planet 9, it showed that not every strange orbit in the outer solar system can be attributed to it. This discovery also supported the idea of multiple medium-sized objects influencing orbits, rather than one large planet. If Planet 9 exists, how did it form so far out? Standard planet formation theory suggests there wasn't enough material in that region to build something so massive. One leading idea is that Planet 9 formed closer to the Sun, near Jupiter or Saturn, and was ejected during the solar system's chaotic early days. Instead of escaping entirely, it settled into a distant, stable orbit. Computer simulations support this, showing that early solar systems often eject planets into far orbits. Another possibility is that Planet 9 was captured from another star. In the Sun's early history, it formed in a dense cluster surrounded by other young stars. During close encounters, our Sun could have gravitationally snatched a planet from a neighboring star, trapping it in a distant orbit. Simulations indicate a 20% chance of such capture under the right conditions. This could explain Planet 9's unusual tilted orbit. It didn't form in our solar system's flat plane but arrived from outside. Both scenarios are plausible, requiring only time, chaos, and gravity, all abundant in the early solar system. After nearly a decade of searching, the hunt for Planet 9 is reaching a critical point. Current tools have largely exhausted their capabilities, but the Vera C. Rubin Observatory in Chile promises a breakthrough. 4-meter Simony Survey Telescope and the world's largest digital camera, Rubin will conduct the Legacy Survey of Space and Time, LSSD, scanning the entire southern sky nightly with incredible detail. This 10-year survey will detect faint, slow-moving objects like Planet 9, down to magnitude 24. If Planet 9 exists within 800 AU and isn't obscured, Rubin should find it. If Rubin finds nothing, that will be significant too, strong evidence that Planet 9 doesn't exist or differs from predictions. Other efforts continue, including citizen science projects like Backyard Worlds. Planet 9 and upcoming telescopes like Nancy Grace Roman and Euclid, which will refine outer solar system models. Planet 9 might already be hidden in old data, camouflaged by Milky Way clutter, or simply dimmer than expected. Rubin's comprehensive survey offers the best chance to resolve the mystery, providing either confirmation or closure. This isn't just about discovering a new planet, it's about completing our understanding of the solar system. Whether Planet 9 is found or not, the search has revealed how much we still have to learn about the distant reaches of our cosmic neighborhood. If you enjoyed this journey through the mysteries of space, make sure to subscribe for more updates. Like this video if you found it fascinating, and share it with others who love exploring the unknown.